First of all, we will study about the number line. Number line. It's quite easy. Number line is starting from the line. Number line, we come from starting. We draw a line to represent the number. Number line is a line that represents the number. Starting with zero, correct? Starting with zero. So the number always start with zero. Second is number one, number two by every step, number three, number four, and so on. That is called number line.
Yeah.
Another point is about the place value. Have you ever heard about place value?
Yeah.
Place value. So we did a little bit introduction about these place value. So place value is the procedures. Let's say, okay, I will draw the place value. Let's say number, for example, number 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is also a number. This is also a number. But what is this called? What is the first digit numbers called? We call it ones, right? One.
Once.
Yeah,
Yeah.
it's one. Oh, one. The second digit is one. The second digit is
Tens.
tens, correct? Tens. Third digit is
Hundred.
hundred. Yes, hundreds. Hundreds. The fourth digits,
Thousands.
thousand. Yes, thousand. Wow, my writing today is not, it's not so bad, so bad. The fifth digit is after
Uh,
thousand is
10,000.
10,000. 10,000. As you may know, in Cambodia we have these kind of word. Even in Chinese we have the 10,000 word. Only American don't have the 10,000 word. So they add and make it 10,000. The
Oh,
yeah.
only Americans.
Yeah, only American don't have like 10,000. They made up like thousand with 10,000. In Khmer we have that's 10,000 as one word.
What is it?
Moon we have like Mapuan, Mamun, something like this. This is
Yeah.
another word. Right. With
And America is the only one that uses Fahrenheit,
Fahrenheit,
isn't it?
Fahrenheit is Fahrenheit is another unit. It's another unit in
Yeah.
yeah
Doesn't everybody else use Celsius or something?
yeah. American they have their own standard, which is U.S. standard something. But in Cambodia and other country we use metrics. For example, the
Oh, yeah.
temperature we have degrees Celsius, American degree Fahrenheit. Why?
I don't know how to tell the. I don't know the difference between them. Like, how do I convert them?
Oh,
Because I'm so used to Fahrenheit.
yeah, we will have the conversions. Even the distance in
It's not that. I know it's never going to pop up, but I actually want to know.
oh we will have stay stay calm patient. We will go into that. And not just the temperature, we also have the distance. Distance, Americans use it
Like we have like
miles,
we
right?
don't. Yeah, it's like miles or something.
Like miles something. But here in Cambodia, we use kilometers. Easier, faster, convenient.
And they have American football and they have soccer, and everybody calls football football, while they have American football and soccer.
Yeah, but even
But it's not even football. You don't kick the ball with your foot. You're not footing the ball.
yeah. Okay, American is like staying alone by themselves.
Yeah.
They make their own units to make it like everyone use with them something like that. Show their power that they have invent something new by themselves and let everyone to use, but no one use. So that's the point.
Stop inventing things that are confusing.
Yeah.
When I go to another country.
So coming back, these will call it 100,000, right? After that,
Yeah.
after 10,000 is hundred,
Mm,
hundred
1,000.
thousand, hundred thousands, thousands, and
And then it's millions.
million, yes, millions. So
10 million.
10 millions,
100 million.
100 millions. How about next one?
Billions.
We call it billion, yes. And then 10 billion, 100 billions. After that, it's trillion, something like that, right?
Yeah.
Okay, so that is called place value. Why place value important? We will see why it is important. And first of all, place value important because we want to address them. Like we want to address the number. What is this called? What is this called? Sometimes you already see uh, the large digit number, but if you study it, you will like, what is this called? Something like this. So, what is this will be called?
What is what?
This number called. How can we address this number? This large number.
9 billion 100 1 million
Hold on. One.
9 123 million not 9 billion 123 million 456,789.
Correct. So 9 billions 100,000
123,000.
20
Wait, no, 123 million. Yeah.
123 million,
Yeah.
123 millions
456,789.
400. Sometimes when I use too much like phone, it's always autocorrects. And then when I keep back to spelling, oh my god, four hundred 56,000 700
89.
89. Yes, that is correct. 89. That is a big number. If you have this much money,
You're rich.
we're rich, super rich. Okay, so that is called place value. Next is expanding forms. Okay, expanding form. Have you ever heard about expanding forms? We expand the place value into our forms. For example,
Oh, yeah, 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 yeah.
okay. For example, we have three, four, five, six. Okay, this number. If we want to expand them, we make it like what? To make it easier to read as well. We make it as if we have 3,456, the number, we expand it to 3,000 plus 400 plus 50 plus 6. That is a little bit easier to read and also to address, like
Yeah.
3,456. Yes. How about we have, okay, this is number, this number. Mm, okay, this number, if we want to make it in the expanded forms, it will be
3,000,000
3 million. Wait, 3 million. How many zero millions?
six
60. 3 million. 4
400,000
100,000.
5 zeros
5 50,000. 50,000 plus 50,000. Okay, 50,000
plus 3,000
plus 3,000
plus 500
plus 500
plus 60
plus
plus 2.
60 plus 2. Yes. So this is called expanded form. Okay, not so hard for you. Next is additions. Addition. So now we already understand about number line, the place value, and the expanded form. That is also helpful when we do the operations. So first operation is additions and subtractions. Addition and subtraction. So addition. So addition, for example one. For example, why we make the additions? Because like sometime in reality, because we know that reality when we have something and then we get another thing, so it's those two combined, uh, it's the adding. For example, you just have had $10 and your mom give you another $20. So logically you know that it's $30 already in your pocket. But
Yeah.
yeah, that's why mathematical exists, to make you easier to consider. So $20 beginning, like you have $20 plus your mom's gave another $10. It will result in thirty
$10
dollars.
and $30.
$30. Yes. Now, when we have the adding operations, what is this called? Have you know before? Like it's in the very,
Addition.
it's
Addition
called
order thing.
it's called
Addition property
add-ins.
order or
Have you ever heard add-ins?
add
That is called
add what?
add,
Add-ins, yeah.
yeah, add-ins. So the number
I
that
thought you were talking about I thought you were talking about the order of operations. You
oh
know what that is?
order operation. So like,
Yeah, it's basically like addition order operation, subtraction order operation.
oh, we will come to the property of the addition, like how it's commutative, something like that, associated.
Yeah.
Yes. But now we just want to address them one by one, like these. When the components of adding together is called addends. What is these called?
That is
The result of the
the
addition is a
the sum.
sum. Yeah, that is the sum. So this is the sum. Okay. Yeah. So okay. Slide. So now, how can we compute the compute operations? Okay. How to compute the addition? Okay. I think you already know that. So to compute, for example, three, eight, what? To compute, for example, 300, 3,274 plus 123. How can we compute this number for the light number?
We add horizontal. We add vertically.
Vertically, so we do the operation by summing number up vertically. So we arrange,
Yeah.
first of all, we arrange the number vertically and place it in the order of place value, right? So
Yeah.
3,274 plus place it in the correct place value will be like this.
Yeah.
And then 4 plus 3, 7.
7.
7 plus 2 is 9. 2 plus 1 is 3. And 3 here. So the result is 3,397. So first of all, in order to operate or compute the additional, we have to line up vertically. And step one, atoms at each place value. What is it's bigger than that? Okay, this, wait,
Yeah.
wait. Oh, I'm still bad with the text, like not so fast. For example, we have another number like 4,187 plus 694. Okay, so in order to compute this, we make it, first of all, we make it line up vertically, right? So
Yeah.
418, wait, 87 plus 694. So in order to add this, when it's more than 10, for example, now the first digits at once of the place value, 7 plus 4 is
7 plus 4 is 11.
11. So we have 1 here. We know that place value can only put 1 digit. Now we have 1
Yeah.
here.
We
How about
carry
another 1? Carry, right? So we carry here 1 to another digit. And then 1 plus 8 plus 9 will be
18.
18. So 8 here and carry 1s again. And 1 plus 1, 2. 2 plus 8, 2 plus 6 is 8.
8.
8 and 4.
And then 4. Yeah.
Yeah.
It's 4,801.
Yeah.
Yeah.
So it's equal to 4,881. So,
Yep.
yeah. So, in order to do the operation, the addition operation, first we line up vertically at each of place value, and don't forget to carry. Don't forget to carry. And if there's greater than 10, so you need to carry as well. Okay. Next, we will talk about the property of the addition. Property of addition. Property of addition. Property of addition is, first of all, we, so first of all, like, for example, 7 plus 0 equal to
7,
7 again. 0 plus
right?
7 is also
7. It's the
7.
same thing. Zero is nothing.
And the same thing. That is called zero property. So when any number adding with 0 will result the same. That is called zero.
Yeah, because zero is nothing. You can
Yes,
add
zero.
zero, but nothing will evolve to the same thing.
Yes. Next is 7 plus, for example, 7 plus 4 result equal to 7 plus 4 is
4, 11. Sorry.
11. Yes. How about 4 plus 7?
11, because it's the same thing.
Because
We
it's the
just
same thing. So,
reversed it.
yeah. So, in addition, we can reverse them. Or in another word, we call it commutative. Commutative
Yeah.
meaning that we can change them to their other positions. Commutative or community or community. Okay. Another. Okay. One more is another like this. Okay. One more is another. You may already know we have, for example, in the operation when we have parentheses, for example, 2 plus 3 plus 6.
We do the things in the parentheses first before moving on.
Yeah, we have to think about the parentheses first. So this is 5 plus 6, which result in 11, right?
Yeah.
How about,
Wait. What? Oh, yeah.
yes, how about 2 plus 3. Whoa, 3 plus 6. Now parenthesis is between 2 and 6. So we do the parenthesis first. So that will be, this is 9,
11.
this is 2, which equal to 11. So the result are the same. So in addition property, even it's the parenthesis here, the result won't be so much, won't be changed. That is
Yeah.
called associative property. Associative. For what? See, oh, associative. So that is associative. Now moving on uh, to the subtractions. Okay. Now, subtractions. For example, we have 9 minus 2. We get, if 9 minus 2 is 9 minus 2
9 minus 2 is 7.
is 7. So, and the component of the first subtraction is called, do you still remember?
Oh, I actually don't know this.
This is called minuends.
I think we learned about this. We did, but
Oh God.
anyway.
This is just a little bit recall, and then we push you to the what you have learned. So this is manuence. How about this? Do you still remember? So the number that subtract them, the first digit here is called manuence. And now the number that have to be subtract, that have had subtracts, this number two is called subtrahend. You heard?
Substrat in?
Yeah, subtract.
We never learned about substrat in or something.
Oh, really? So this is called subtrahend.
Yeah.
How about the results? The
We
result
have so we have quotient, we have
of quotient is division.
the like division.
Yes. But now the result of subtraction is, I think you have heard a lot.
No. I gotta take my notes out for this, bro.
Yes, 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 please.
Can I take my notes out?
Yes, yes.
Oh, and I just teared my paper out. Wow.
Mhm. Okay.
The difference.
Different. Yes, that the difference.
My God.
Difference. That's called difference. Sometimes you need to recall something you
Yeah.
learned very long times ago, and now, yeah. Okay. And when we talk about the, okay, so it's not very hard. It's just a little reviews. Now the the property of subtractions. Property of subtraction. Can subtraction be commutative? For example, why? Okay, still got not yet familiar with this yet. Oh, let's take time. Example, for example,
Yeah.
uh, 4 minus 7 and 7 minus 4. We know that if addition 4 plus 7 and 7 plus 4 will be the same answer. But now in subtraction, 4 minus 7 and 7 minus 4, is it commutative?
What do you mean by commutative?
Commutative is we can exchange them here. 7 plus 4 equal
Like if we
to,
like exchange them around?
yeah, we
Like
can exchange them.
no, because 4 is smaller than 7.
Yes, but for the subtract, for addition, we can commutative, I mean exchange them from this place to this place and add them together, will result the same. But for
Yeah.
subtraction, it's not commutative, meaning that we cannot exchange them. So
Because 4 is smaller than 7, so they can't subtract.
yes,
You know?
not commutative. So yeah, I just wanna like confirm that it's not something like when we do operations, some students still like are mistaken on that in integer. When we study the integers, it's like it's minus 3 or 3 plus 3 still.
No.
Yeah. Okay. So how about, okay, another operation is when we do the large number. Yeah, when we do with the large number. When we do with a large number, for example, when we have 958 minus 48 will be, so in order to operate these subtractions, we need to
Vertically
vertically do so. Yeah,
subtract them and put them in their place value.
yes, correct. So 958, put it in the place value vertically. Oh, and getting like
910.
910. Yeah, 019, 910. But another example, if we have 900, oh my god, 900 minus 324, we will have
We will have.
line up vertically still and 324. Now, can we subtract 0 like 4 from,
No, we have to turn it to 10 and then turn the next 0 into 9 and then turn the next 9 into 8.
okay, so these we change it to 9, right? 9 minus
Yeah.
4
No,
is
no, no, we turn that to 10.
turn it to 10. Yes, yeah, yeah. Okay, we turn this to 10. So 10 minus 4 is
10 minus 4 is 6.
6. So here it's already, it should be 10, but already given one
So it's
two
9.
digits. So it's 9. So 9 minus 2 is
7.
7. Yes, 7. So this already, someone borrow one number already. So it's
Yeah.
right. H minus 3 is 5. So
That's
answer is
576.
576. Another operation, another method to operate the subtraction, it's like a hack. It's like a hack.
Like a hack?
Yeah, like a hack, like life hack, something like math hack. Let's say math hack. If this
Yeah.
number is like 900, it means like it's already greater than 300. We already know, right? It's already know that it's bigger than 300. So what we do is make it to the bigger number. So subtract this by 1. Subtract
As you
900 by 1.
are you writing on it?
Yes. Oh, wait. Oh, okay, okay. So subtract it by 1 and subtract this number by 1. So it will be 899 minus 323. Correct?
Yeah.
Yeah, it's like that. And now let's see the result. Will these the same or different? So the operation, the result of this will be 8, let's say 899 minus 323. So this number may be easier. Do you think so? Like if we borrow from one, it's sometimes it's got confused. So if we come to like 900 minus 300 something, just subtract one from here and subtract one from here. So it will
Okay.
be like 899 and this is 323. So when we subtract 9 minus 3 is
Uh 6, yeah.
6. Yeah. 9 minus 2 is
7.
7. 8 minus 5, 8 minus 3,
5.
5. So that is the result.
Does that work every time?
It's work every time. Work every
Okay.
time. For example, okay, maybe we give one more example so that like you really believe, right? Because in this case, maybe it accidentally corrects, but it should be like, okay, throw me some number.
Do I use some random number?
Yeah, random number, but should be,
24.
but that should be like 00, or add a number but a smaller, like the other two digits should be smaller than this, so we can subtract more than
16?
60.
No, 16. I thought. Oh, all right. 44 then. 44. Is it like should it be like a big number or like a small number?
The big number subtract by one big, one another big number, but it's not biggest big until this.
44 and 55.
44 and minus 55. So, but this is like that. But this will be in the negative number, right? It will be
Yeah.
when you study it will be in the operation of integers. Now we want
Oh, this is a negative number.
the,
Oh,
that's the negative numbers. Okay, let me give the example, then you can realize what I am intending to. For example, 700 minus 55, like you say, 55.
yeah.
Okay, 55. So this is will be positive. That's what we want to know. So if we want to do simply what we do is 700 minus oh, minus 55, we will have, okay, like normal things we will do like this. So this will be 10, correct? 10
Yeah.
minus 5 is 5, and then this is 9. So 9 minus 5 is 4, and then this become 6.
A six.
Yeah, so
So
600,
it's 645.
645. But what we do is something different from them is, oh, we do like this. Why cannot be much? Okay. Okay, a few more minutes. Why irregular not work? Okay. Okay, reason not even work. For example, okay, we have 700 minus 55. This we need to borrow from one to one digit, from one to one digit. So it's quite complicated. So we subtract one number from here, from the manuend, one number from the subtrahend. So it will be like 700 minus 1 is 6.
It's 699 and
Yeah,
54. Oh,
54, yes. Now, my do this operation easier, right? Because
yeah. So
bigger number minus small number. So 9 minus 4 is
9 minus 4 is 6. Wait. No, 9 minus 4 is like 5, right?
5, yes. Minus 4 is 5. 9 minus 5 is
4. And then
4.
645. This is amazing.
Yeah,
Does
so
that
it
does this only work on like bigger numbers?
bigger number minus smaller number. It's work all the time. Even smaller number minus smaller number, but we will study in the integers.
So
Maybe
so like 13 minus 12 you remove.
it will be the same. Like we subtract ones by each of that. Like the menu end subtract by
Mhm.
one, subtract and minus by one. The result will be the same.
So 3 minus 2 like 2 and 1 it's 1.
3
But
minus 2, for example, 3 minus 2, but this is like very easy one, right? It's 1. How about 2 minus 1? Will the result the same? Because,
no, cuz then would 1 would just turn into a 0, right? 1 minus 1 equals 0.
no, 3 minus 2 is 1, correct?
Oh, I think you're talking about 2 minus 1.
Yeah, 2 minus 1 is 1.
2 minus 1
The
is
same
1.
number,
Yeah,
right?
this works.
That's work all the time. That's work all the time.
Yeah.
But when you subtract menu n by 1, don't forget subtract and also reduce by 1 as well. If you don't reduce this, that the problems. Okay. Okay, that is the property of integers. So next we come to rounding number. Yeah.
My candle accidentally went off. Oh,
Oh my god, why this compound? Why this
okay.
compound? Oh, this. Oh my god. Okay. becomes the okay. Now even the erasers is not cannot be erased here. Why? Do you see still like the draft here?
Yeah. Can it not be erased?
Cannot. What's happening?
Hold up. Wait, one second.
New ones and it's like okay.
I lost my whole pencil case.
Oh.
I know I put it in there because I took a marker out of it to check my agenda, right? And I put it back in there. It must have fell out during the car ride or something
Oh,
because
maybe
I
in
did
school.
nothing to it and it was still closed when I came home.
Oh, that is okay. I remember when I like was in the junior high or in the primary school, I always lost my ruler. Like ruler every time I go to study one day.
No, but I haven't opened this backpack ever since I got home from school, and I know I put my pencil case in there because I took a marker out of it and then I placed it back in my bag, right?
Mm,
And then I put it in the car and I never checked on it, not once. I never even opened it. But I
mm.
don't know where it is now. I checked my whole backpack.
So it must be teleporting.
No, because this literally happened to me like
On,
on Friday.
oh, shoot.
This happened to me on Friday because like I was literally playing tag with my friends in the hallway, right, with my backpack,
Mm-hmm.
and I put my sunscreen. It was closed. There was only a tiny hole, but when I came back in the classroom, gone.
Mm-hmm.
I like that sunscreen and I like that pencil case. Please give it back.
Hmm. That's sad. That's sad. Ooh, someone must be stolen. Maybe.
Are you still struggling to erase it?
Yes. Why? Name. What is happening? It's your it's like we have a marker, like in we have a marker that unerasable. But now I use this maybe. Why?
Sorry.
Marker that unerasable. Kind of this.
There. Sorry. 1 second.
Okay, okay. Mhm. Okay, so whatever here, you ready? So just ignore this background, like a steel keyboard and everything. So we will use this with the other color. So, for example, we have example we have two rounds. Mhm. Round number, let's say 278, 751 to the nearest
Yeah.
10,000. So we want to round this number to the nearest 10,000. What shall we do? What shall we do?
We check the nearest 10,000s and then we check the number next to it to see if we like round it higher or not.
So first of all, we mark, let's say mark the digits. So nearest 10,000, so mark the 10,000 digits, which is, for example, here. And then we look to the rise,
Yeah,
just to the rise.
1 second. Sorry.
Okay,
Okay.
okay. So to round this number at any digits, when we ask to round to the nearest 10,000, so mark the 10,000 digits first of all, T, for
Yeah.
example, here, and then look to the right. Look just to the right, just one digit to the right, which is 8, right? Which is 8.
Yeah.
So when it is, as I have in, I have told you once, if it's greater than 5,
We round it higher, but if it's not greater than 5, we either like keep it the same or like
keep it the same, and the rest will be 000, right?
yeah,
So for this, in this case, to the nearest 10,000, we mark
it's
this.
higher than 5.
So it will be
280,000.
80,000, yes. So the rest will be 000. How about if we round it to the nearest 100,000? 100,000.
We look at the 100,000 and look at the number next to it
Yeah, so we look,
to the
we
right.
mark this number. So our purpose is to make the number 2 to be rounding ups, or still put it there, and the rest will be 0. So
Yeah,
look at just to the right, which is number 7. So
and the 7 is higher than 5, so it's 300,000.
yeah, 300,000. So if we round it to the nearest 100,000, it will be 300,000.
Yeah.
What else we have another? For example, we have 1, 2, 3, 1,234. Round this to the nearest hundreds. So first of all, we mark the digits of hundreds, correct?
Yeah.
And
And it's 1,200 because the number next to it is lower than 5.
lower than 1 is 3, so it's lower than 5. So rounding will be 1,000 200 0.
Yeah.
Okay, so to round, it's not very hard for you. Another point is called estimation. So first of all, what is the benefit of rounding? Because sometimes you may don't want to have like, for example, if you have,
Like
yeah, if you're running the large business, for example, if you're running a large business, your friend asks you like how much profit you have, and you say like 2,300,000, 1,000.
that's a lot.
That's yeah, like 3 million 300
Like
four
if you say
thousand.
like
And
then you just like do you want me to say or should you?
yes, 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 yeah. It's quite accurate, but we don't want to hear that. What we want to hear is $2.3 million.
Like the number like about, you
Yeah,
know? Like
that is enough. Like if you want to hear like how much money do you have in your bank account? $2.3 million. Yes, that's enough.
3,545 1/10.
Yes. Okay, another one is, oh my god, still this come again. Another one is estimations.
Okay.
Estimations. Estimation. Also, the first thing we also need to know in reality as well. So estimation
Yeah.
is what is similar to roundings, but rounding is just one number. But when one number adding to one number, like if you round here and adding together, it's called estimation. Like if you have a lot of data, so sometimes somebody just asks you to, what is your result, and then you can estimate the result by rounding those number and then and
Like guess the result or
yeah, it's like guessing the result. Estimation is like guessing the result.
oh like so the answer of 4 times 4 should be about 16 or something, right?
For example, like reality. For example, you run, let's say, three business. You're running
Yeah.
three business. First one, you like one shop A. Let's say shop A. Your profit is 1,325. Okay, let's write down. So shop A is 345,232. Shop B is 551,080, and shop C is 123. So somebody just came to you and asked, "What is your total profits by this year?" Then you don't want to like sum up all of this and give them the accurate result, right? Sometimes we don't want to hear like, okay, 1,245,320 a year, right? What they
Yeah.
know is like 1.2 million or 2.3 million. So first of all, we round this up or down, round this number. This number, if we round to the 10,000, it will be
10 3,300 uh 500 350
550. Yeah,
3,500,000. Oh my god.
yes, 350,000.
Yeah.
Yes, and this shop like profits will be
560,000.
five hundred
Wait, no, 550,000.
50,000. Yes, $50,000. And then, oh
120,000.
yeah, shop C will be $120,000. So you can just add these up and give the answer to them, easier. It's easier.
Yeah.
It's like, okay, 10. Okay, when we do the calculations, like we just a little bit pop up in our mind, and it's great. I'm good on this. Now it's unerasable. Oh my god.
Oh my
So it
god.
will be like 0, 0, 0, 0, 0, 10 to 1. Yeah. 5, 5, 10
Yeah.
to 12. Well, we carry 1 here. So 8, 10. So what we want to know is 1 million and 02. It's still like a 1 million, or sometimes you round it this, then it will be 1 million. So if someone come to you and say like, how much profit do you make? It's about $1 million, something like that. So it's like
Yeah.
estimation. So that is the estimation is the result of rounding of the whole data. That's
Oh,
estimation.
alright.
Yes, estimation is the round. So it's a rounding of the whole data. In, in short. So in order to make the estimation, we round the number first and adding up. If we add it first, the number is still complicated, right?
Yeah.
Add first and get the accurate number, and then we round this, and the result will be like we need to use our brain a little bit harder. But if we round it first and get the result, it's quite easier.
Yeah, it's quite easy.
Easier.
It's just the whole amount of like the rounded number, you know? Like
Hmm.
yeah.
Yes. Okay.
It's very
Okay. So yes, we will continue tomorrow.